It's time to use a buzzer. So there are two main types of buzzers, active and passive. A passive buzzer emits a tone when a voltage is applied across it. It also requires a specific signal to generate multiple different tones. An active buzzer are simple to use, and they are covered here. We can see that this buzzer over here has a positive side on one end and the brand name HSD on the other. There's also two prongs on the bottom. One of the prongs is slightly longer than the other for the positive side versus the negative side, which we can also see via the plus that's on the top over here. So we're going to be plugging this into our circuit in a second, but let's keep going with the instructions. Connecting a buzzer. An active buzzer can be connected just like an LED, but they're a little bit more robust. You won't be needing a resistor to protect them. So we won't be needing to use one of these to reduce the resistance. We can use the voltage that the Raspberry Pi provides. So to set up our circuit, we're going to create a simple circuit like it shows below. We can see that the positive side is going to be facing one way, and that this lead over here is the positive lead, which is getting plugged in to general purpose pin number 17. This is the negative lead, which is getting plugged in ground over here. To hook up this buzzer, we're just going to place the two prongs anywhere in one of the rows on the end that leaves a little bit of space after it. The row doesn't really matter. So from here, we're going to wire it up, and we're going to notice on the buzzer, the positive side is this way, which means that underneath it, the prong on the right side is the longer side, the anode, the long positive lead. So I plug those in over there, and then you'll notice that these are spaced 4 apart. So if I were to place this prong into one of them and to place into another, that these are 4 prongs apart. So we're going to need to do that when we plug in our wires over here. We were going to wire them 4 prongs apart. So this negative lead just has to be plugged into ground, and we have a lot of different ground ports. So if you look across the mat, we can have lots of different ones. So the one that I'm using over here is this brown cord is 4, if we count up 1, 2, 3, 4. So on the right side, 1, 2, 3, 4. So I'm plugged into that ground pin over here. So this ground negative pin is going to get plugged into 4 prongs away from that yellow one. So 1, 2, 3, 4 into the negative lead of the buzzer. And now this buzzer is wired, and we can kind of ignore this. This is still working, but we're working with the buzzer right now, which is fully wired. So to get this wired, we can see that this yellow wire is 1, 2, 3, 4, 5, 6, 7, 8 prongs down on the right side. So if we take a look at the map and we count 8 down, 1, 2, 3, 4, 5, 6, 7, 8, I'm in GPIO number 23 over here. You could use any GPIO, you just have to make sure that it's plugged into the right one. So this general purpose pin is going to be where I plug power into. So this pin over here needs to go into the same row as the positive lead of my buzzer over here. Make sure that your buzzer is in the same row by kind of lifting this up, and make sure that that prong is in the same row, which it is. And then we can see over here in that side, we're going to place the negative lead of the GPIO. So to write the code for our buzzer, we're going to start with from GPIO 0 import buzzer, and from time import sleep. Then we have to make sure we figure out which GPIO pin our buzzer is in. So if we go over to programming and we go up to Thani, we're gonna be creating a new program over here. And notice I've put my buzzer is in GPIO pin number 23, and that's because this yellow wire is in the GPIO port number 23. So their default was 17, but I had to change that to 23. And then they say over here, GPIO works like an LED, so try adding buzzer on and buzzer off. So they mentioned into your loop. I'm going to do a loop, but first up, I'm just going to run it like this. I put buzzer on, sleep 1, and then buzzer off. So if I run my program over here, it's going to first ask me to save it, but it will run. I'm going to save this file over here, say buzzer version 1. I click OK at the bottom over here to save that. And then, yes, it is buzzer.py. So if I run this over here, we'll notice the buzzer goes on for 1 second and then turns off. If I say sleep over here 3, the buzzer will go on for 3 seconds and then go off. Notice that there's nothing that we're writing to change the tone. It's just buzzing at the same frequency. Now I could say over here, buzzer on for 0.5 seconds, then buzzer off. And then let's say I want that to repeat over and over and over a couple of times. So I could say for I, we're using a for loop. Let's say I want it to happen 5 times. So for I in range, colon, and then I have to indent buzzer on, sleep 5, buzzer off. And for how long should the buzzer remain off? Let's also do a sleep 0.5. So put that on that line over there. And we can see, indent that. The sound might sound familiar. So we're 5 times repeating the buzzer on, sleep for half a second, off, sleep for another half a second. I could modify that so it stays on for half a second, or for 1 second, then off for half a second. Might sound like the microwave noise. So these things are all using a buzzer. Items like your microwave all the way to this smoke alarm that's in the top of the room. So this buzzer over here, we're able to control with our code using a sleep command over here. Now this project uses while true. This is gonna keep the buzzer on forever. So if I change that to while true, it might be a little bit annoying, but instead of using for I in range, I'll say over here, while capital T in true, colon. If I run this, it's going to run forever. While true means do it forever, and the only way to get it to stop is to stop it while the ping is off. If I stop it while the ping's on, it's just going to remain on. If I run the program again, it'll start again. So I have to stop the program over here while it's off to get the buzzer to go off, so you don't annoy everybody.